On Ethereum, tokens like USDC follow a standard called ERC-20. So what does that actually mean, and what functions do developers use to interact with it? Hi, I'm Elton, and I work on the developer relations team at Circle. Welcome back to Stablecoin 101, a series by Circle where we break down the foundations of stablecoins and how they are powering the new internet financial system. In our last video, we explored how USDC works across different blockchains and how it conforms to the native token standard on each network. In this video, we're focusing on Ethereum, where USDC was first launched and how it works as an ERC-20 token at a smart contract level. We walk through the functions that power USDC on Ethereum, how developers can interact with them, and what's happening under the hood. USDC on Ethereum is implemented using the ERC-20 token standard, a widely adopted interface for creating fungible tokens on the Ethereum network. Since each token is identical and interchangeable, ERC-20 tokens are ideal for currencies and payment flows. This is exactly how USDC is used for on-chain applications. Because it conforms to this standard, USDC can be integrated into any Ethereum-based application like wallets, exchanges, or payment flows using the same functions expected of ERC-20 tokens. Let's take a closer look at those functions, how they work, what parameters they take, and how developers typically use them in practice. We'll focus on 4 core functions you interact with when working with USDC: approve, transfer from, transfer, and balanceOf. The approve function is similar to telling your bank to authorize a utility company to deduct a fixed amount from your account. You're not transferring money yet, just giving permission for a future transaction to happen. This function takes 2 parameters. First is spender, which is the address you're authorizing to pull tokens from your account. The second is amount, which is the maximum amount of USDC that address is allowed to spend on your behalf. The transfer from function is the utility company actually charging your account on the due date using the permission you previously gave. When working with USDC, the transfer from function takes 3 parameters. The first is from, which is the address the USDC will be put from, usually the one that called approve. The second is to, which is the recipient address. And the third is amount, which is the amount of USDC to transfer. The transfer function is like manually paying your utility bill, where you enter the amount, the recipient, and send the payment by yourself. With USDC, the transfer function takes in 2 parameters. The first is to, which is the recipient address, and the second is amount, which is the amount of USDC you want to send. Finally, the balanceOf function is like logging into your bank account to see how much money you have before making a payment. For USDC, the balanceOf function takes 1 parameter, account, which is the wallet address you want to check the balance of. While these ERC-20 functions are standard, most production-grade contracts, including the ones Circle uses for USDC, are built with additional safeguards and architectural patterns behind the scenes. That's because interacting with tokens on-chain isn't just about functionality, it's also about reliability, security, and upgradability at scale. Beyond the standard ERC-20 functions, USDC also includes additional administrative capabilities, such as minting, pausing transfers, or blacklisting addresses. These aren't functions that everyday developers interact with directly. Instead, they're part of the broader infrastructure Circle uses to manage USDC securely. USDC on Ethereum also uses a proxy contract architecture. This means that when you interact with USDC, you're actually interacting with the proxy, not the contract that contains the logic itself. All of the state variables like balances and allowances live in the proxy contract. The logic, the actual implementation of functions like transfer or approve, lives in a separate implementation contract behind it. This design, based on patterns like those standardized in EIP 1967 and provided by libraries such as OpenZeppelin, allows Circle to upgrade USDC's logic over time without changing the contract address that developers and applications are familiar with. So while the logic can evolve, the interface and address remain consistent, ensuring continuity for any app that integrates USDC. So to recap, USDC on Ethereum is implemented as an ERC-20 token using functions like approve, transfer from, transfer, and balanceOf. Under the hood, USDC uses a proxy contract architecture, which allows Circle to upgrade logic over time without changing the contract address. These design choices make USDC stable, upgradable, and developer-friendly within the Ethereum ecosystem. In the next video, we'll put this into practice by walking through your first USDC transaction on Ethereum using live code and our developer tools. And if you haven't yet, check out the rest of the Stablecoin 101 series to keep learning how USDC works under the hood and in the real world. Don't miss it.